6. Does that work right? There we go. Okay, so basically it's just a review of a little bit of everything: sine, cosine, and tangent. So we're calculating or writing the expressions based on this angle, but we're missing an angle. Okay, I'm only going to do one of these. You can have the other one for extra practice. So we need to find the missing angle, the right triangle. So there's my C. Remember, that's the most important one. So we're going to do 7 squared plus x squared equals 10 squared, c squared. 7 squared is 49, 10 squared is 100. So when we subtract that, we get 51. Square root both sides. And I'm just going to turn this into a decimal since we're going to be writing it as fractions. X is approximately 7.1. So that's rounded. Now that we have all three sides, we can write the sine, cosine, and the tangent of theta, or the angle, the unknown angle. Remember, we're looking from here, so sine, from here, sine is opposite over hypotenuse. So opposite is way over here, the 7, and the hypotenuse is 10. Cosine is the adjacent over the hypotenuse. Well, the adjacent's right here, 7.1 over the hypotenuse, which is still 10. And then tangent, TOA, is opposite over adjacent, so that's 7 over 7.1. And that's it. All right. Now, on these, this is just a review of how to line up triangles and prove congruency and test the rules. I'm going to do both of these because it's different rules. So we're going to have two triangles, and it doesn't matter how you draw them. A, B, C, X, Y, Z. And you go through and mark. A is congruent to X. Z is congruent to C. And BC is congruent to YZ. Then we label AAS, AAS. So the answer is yes by angle, angle, side. Remember, if I go too fast, you can always hit pause. Okay, now this one, whoops. This one's a little bit different because it says perpendicular. C and A are perpendicular. So I know I have a right triangle here. So I'm going to put A here. Now it says AC and AB. So A has to be at the corner. So then I'm going to put X, Y, Z. It says CA and AB are perpendicular, and XY and ZX are perpendicular. CB is congruent to XY. Sorry, CB is congruent to ZY, and YX is congruent to VA. So, if we looked at this, we have angle, side, side. And we know we do not have that rule. That's a no-no. But remember, we always have to second check when we have a right angle. Here we have the hypotenuse, and here we have a leg. So the answer is yes by hypotenuse leg theorem. So always remember to check yourself. Okay, determine which of the two angles has a cosine of 0.5. So we're going to look at the cosine of A and the cosine of B. So we're looking from two perspectives. So from A, remember cosine is adjacent over hypotenuse, ka. So from A, the adjacent is root 3. And the hypotenuse is 2. That's a 3. For the cosine of B, the adjacent is 1. And the hypotenuse is still 2. Well, you can clearly see what this is, but we'll do the decimal anyway. This is 0.8660, and this is 0.5000. So, which one has a cosine of 1/2? That would be B. Okay, now we have a new thing where it's the same concept, it's just the inverse. So this is where we're going to learn how to use the calculator of the inverse, tangent, sine, and cosine. So we've been finding the sides given the angles. we're going to learn now how to find the angles given the sides. And I'll just leave this here for you and just dive into the problem. You can come back and look at it. So it says let ABC be acute angles. Okay? Use the calculator to find the measure to the nearest tenth. Okay, so what we're going to do here is we're trying to find this angle based on this decimal. Okay, so I'm going to use my calculator. If my calculator will turn on. Oh, it's because I have my marker still in my hand. So, okay, there we go. So, if I wanted to find this, the value of a tangent of an angle, I would just hit tangent and type in the angle. Like, let's say tangent 35. And that gives me a decimal. Well, we're trying to go the opposite direction. So we need to hit the inverse of these things. So since we're doing inverse tangent, we're going to hit second tan. And then type in 75, enter. Oops, sorry, it's 0.75. That was my bad. Tangent, second tangent, 0.75. That makes a huge difference. And there we go, 36.86, and it says round to the nearest tenth, that's 36.9. Okay, now let's check that real quick. The nice thing about this is we can check. Hit tangent of 36.9, 0.75. So you can actually go back and check your work. So let's do B. Sine of B is 0.87. So we're going to hit inverse sine, second sine, 0.87. Enter. 60.45 or 60.5. Again, the beauty of this is you can take your calculator and do the sine of 60.5. Bam, 0.87. Thing of beauty. Okay, and then C, which is under the calculator, is 0.15. Cosine, just hit second cosine on the calculator, and then 0.15, enter. 81.37, so 81.4. I lied, it wasn't on the calculator, it was down here. Again, you take our calculator and do cosine of 81.4. There you go. 0.149, which is 0.15. So, make life easy. Check your work. Okay, now it says the solve a right triangle means find everything. Everything is missing. Okay? Given the information. So, on this one, it says solve. What we need to find is this, this, and this. The two missing angles and the missing side, which we're going to do right now. Now, to find the missing side, we're going to go back to our old friend Pythagoras. We're trying to find the hypotenuse, c, so that's going to be 2 squared plus 3 squared equals c squared. C squared equals 13, so c is the square root of 13, which is approximately 3.6. Write that in right there. I have all three sides. Now I need to find the angles, which I can do using trigonometry. So, I'm going to find, let's say, B. It doesn't matter. You can do B or A. It makes no difference. And I could use sine, cosine, or tangent. It makes no difference. You just pick. I'm going to go with tangent. So the tangent of B is opposite to over adjacent 3. Okay? Now I'm going to use my calculator and do the inverse tangent. So second tan, 2 divided by 3, 33.69 or 33.7. So this is 33.7 degrees. Now, I could, if I wanted to practice, I could do the same thing for A with sine, cosine, or tangent, or I already have 90. I have 33.7, add those together, subtract that from 180, and I get A is 56.3 degrees. Again, you can do it any way you want. If you wanted to do sine or cosine of B, You could have done A, you could do both. It's your choice. You're in control. Number 4, similar idea here, but this time we only have one side. But we do have an angle. So we're going to go the opposite direction. We're going to do sine of 25 equals, I have to use sine because the only thing I have is the hypotenuse, right? So I don't have to use sine or cosine. Okay? And I'm going to use both actually. So sine of 25, again, sine is opposite over hypotenuse. So that's going to be h over 13. I simply just multiply both sides by 13. I take my calculator. I take 13 times sine of 25, and I get 5.49, round to the nearest tenth, that's 5.5. So h is 5.5. Now I'm going to do cosine. Cosine of 25 equals g over 13. Again, cosine is adjacent over hypotenuse. This is the same mathematical way. I'm going to type in 13. I'm not going to show you on the calculator because it just did. But 13 times the cosine of 22 tells me that side g is 11.8. And the last thing I need to find is angle G, which is very easy. Because I have 90, I have 25. Which means if I subtract that from 180, I find out that angle G is 65 degrees. And now our last example, real world. So we have this stage here. It'll be 30 feet long, so that's the upper part. The hypotenuse is 30. It'll be hard to see. Oh, it'll show up. That's the hypotenuse, is 30. And the rise is 2. Well, from this angle here, this is opposite, which means I need to use sine. So, the sine of this unknown angle, which I'm trying to find, is 2 over 30. So I take my calculator, I put my marker down, I do inverse sine, 2 divided by 30, and I get 3.8 degrees. And that is the degree measurement right here. Very small angle. And that's it.